Hi everyone, this lesson is for geometry students. This is chapter 7, lesson 7.2.2 and 7.2.3 for properties of rhombi and proofs with congruent triangles. We are on day 6, so let's get started. One of the first things we're going to do is just basically review the characteristics of a parallelogram. So number one, one of the things that you should know is that in a parallelogram, both pairs of opposite sides are parallel in a parallelogram. So both pairs of opposite sides are parallel. Additionally, in a parallelogram, one thing that is another characteristic is both pairs of opposite sides are congruent. Number 3, for a parallelogram, and let me draw another one, is that both pairs of opposite angles are congruent, so that's equal to that. And I'll put number 4 up here. For number 4, the diagonals in a parallelogram, both of them, bisect each other. Now, they're not the same length, but they do bisect each other. So that length is the same as that one, and this length is the same as that one. They cut each other in half. And for number 5, the last characteristic of a parallelogram is that one pair of opposite sides are both congruent and parallel. So that means that it's a parallelogram. This quadrilateral is a parallelogram if this pair of opposite sides are parallel and the same pair are congruent. So again, you could put that the other way and say, well, that line, that segment there is parallel to that segment, and additionally, that same segment is equal to that segment. If you have any of these characteristics, 5 characteristics, then those quadrilaterals being a 4-sided shape, are in fact parallelograms. So today we're going to just prove properties. We're going to do a few proofs, and actually we're going to start off with a proof. So what we have here is given that segment AB is congruent to segment CD. We also know that they're parallel. And what that means is if they're parallel and they're congruent, what that actually means is it's a parallelogram, right? It's one of our characteristics that we just went over. So what I would do for this problem here, first off, is I'm going to write my given statement. So I'm going to write 1. Number 1, we have segment AB is parallel to segment CD, and also segment AB is congruent to segment CD. And so number 1, our reason is that they gave us that information that's given. Now, our objective is to prove that angle A, this angle here, I'm thinking is congruent to angle C. So what I'm going to do is I'm going to fix that right now because I know that's not correct and I can't fix that. So I'm just going to cross that out and make, oops, let me fix that. That's why I can't fix it, because it's a solid. This should be C. Okay. So we're trying to prove that angle A is congruent to angle C. Now, what you do need to know is that, number 1, given that both pairs of opposite side, one pair of opposite sides is congruent and parallel, we know it's a parallelogram. So we actually know quite a few things. Number 1, we know BC is congruent to AD. We know that because it's definition of a parallelogram. Because these right here, these two things make it a parallelogram. And if BC is congruent to AD, I also know that BD is congruent to itself by reflexive property. So I could prove, in fact, these two triangles congruent by side, side, side. If I didn't say that AD was congruent to BC, and because I know that those two lines are parallel, what that also means is that this angle in here is congruent to this angle in here because alternate interior angles are congruent. And if that's the case, then I have, and remember, we can't use angle A and angle C, right? We first, before you can prove that the angles are equal to each other, you have to prove that, before you can prove that the angles are congruent, you have to prove that the triangles are congruent, okay? I'm just completely overlooking this one thing, is that if this is indeed a parallelogram, then the opposite angles are congruent. I could say angle A is congruent to angle C by definition of a parallelogram. However, I'm guessing that they want us to first prove that the two triangles are congruent, so we're going to do that. So number 2 would be, based on the given information that AB is parallel, that would make angle ABD congruent to angle CDB. And they are congruent because alternate interior angles are congruent. Okay. So we know that that angle equals that angle. Now, additionally, I know that BD is equal to itself. So I'm going to say that. So I'm going to say line segment BD is congruent to line segment BD. And that is the reflexive property of congruence. And then now that I have side and angle and a side congruent to a side and angle and a side, I can now say that the two triangles are congruent. The triangles, so I'm going to say triangle ABD, so ABD is congruent to triangle CDB by side angle side. And once the two triangles are congruent, then I can actually say all the parts are congruent. And therefore I can say angle A is congruent to angle C by CPCTC. Okay, cool. So for this problem here, we're going to try to find the diagonal of the cylinder. Now, I do know that a height is perpendicular, which means that's a right angle. We also know that I could draw in this right triangle right here. And what that would do is I could use Pythagorean Theorem to find the diagonal. Now, we know that this length is 8 because that's the same length on both sides. And additionally, I know that if my radius is 3, then the whole length is going to be 6. And because this is a cylinder, and I noticed that this is a special, not a special right triangle, but it's one of our Pythagorean triples, 6, 8, 10. Remember that one? So I know that the length of the diagonal is equal to 10 feet. Now, I will say that if I forgot that, I can just say, okay, that's my diagonal. I don't know what that is. And I can use Pythagorean Theorem, which is 8 squared plus 6 squared is equal to my diagonal squared. So I have 64 plus 36, which is 100, is equal to my diagonal squared. And then my diagonal is going to be the square root of 100, which is 10. For this problem here, we're going to write what we know about a rhombus. Now, remember, a rhombus is a quadrilateral, but also a special parallelogram. So remember, you've got your quadrilaterals, right? And from your quadrilaterals, you have your trapezoids, you've got your kites, and then you have your parallelograms. Now, a parallelogram has, these are my parallelograms, a rhombus, a square, and a rectangle. Now, remember that all of the features that a quadrilateral have, meaning 4 sides, and that the sum of the angles is 360, fall into a parallelogram, which means that all those 5 things that we talked about in the very beginning of the lesson, those 5 are characteristics of a rhombus. So in addition to having opposite angles congruent, both pairs of opposite sides parallel and congruent, besides all those facts that we already know, that opposite sides are parallel and congruent, etc., all of that information, in addition to that, this is what they want to know, in addition to the 5 things. So additionally, we have 4 congruent sides. That's one thing. For a rhombus has 4 congruent sides. A rhombus has 2 consecutive sides that are congruent, then it must be a parallelogram. A rhombus has diagonals. Yes, they bisect each other, but the diagonals, there's 2 things about the diagonals that is very important. Number 1, the diagonals are perpendicular, meaning they form a right angle in the middle here. And not all parallelograms do that. Additionally, the diagonals bisect each of the angles, and only a square does that. So they bisect each angle. So not only are the opposite angles congruent, right? So like, let's say that's 100. that would be 50, and then that would be 50 as well because they are bisected. So we have 4 congruent sides, we have diagonals perpendicular, and then we have the diagonals that bisect each other, in addition to the 5 characteristics of a parallelogram. So here we are, we have a rhombus, PQRS, and so we already know that all the sides are congruent, okay? So you would say that based on this information, we're trying to prove that triangle PQR is congruent to triangle RSQ. Well, number one, what's given is that this is a rhombus. So I'm going to say rhombus, PQRS, and I'm going to distinguish this as a rhombus because it has 4 congruent sides. Number 2, I'm going to say that PQ, line segment PQ, this segment, is congruent to line segment SR. So I'm going to say that it's congruent to line segment SR. I'm also going to say QR, line segment, is congruent to line segment PS. And the reason for that is the definition of a rhombus. A rhombus has 4 congruent sides. So both pairs of opposite sides are congruent. You also could, I want to say that the both sides are congruent and not just say it's a parallelogram, because that wouldn't mean that PS is equal to QR. All right. Number 3, we're going to say that PR, line segment PR, is congruent to itself. So PR is congruent to itself. And if PR was equal to itself, that would be the reflexive property of congruence. And then lastly, I have the 2 triangles are congruent. I can say triangle PQR is congruent to triangle RSQ. And the reason for that would be, number 4, would be side, 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 because all the sides are congruent, or opposite sides are congruent. For this proof, let's see what's happening here. This looks like a little crazy. Let's see. Okay. Oh boy. All right. So what we see here is that STR, I'm just going to put this right back on here. What I see is that I have another rhombus, and I'm trying to prove that STR, this triangle inside, right here, is congruent to this triangle up here. All right. Now, I know that they are mirrors. I know they reflect each other and all that, but let's just see what we do here. So we're going to start with the given. Number 1, we're going to start with given. Number 1, we know that we have rhombus. Let's see if this will work. Yep. So I've got rhombus, PQRS, and the reason for saying that is given. And number 2, let's see what we have. We have a rhombus. Now, in order to prove, we need a plan of action. In order to prove these 2 triangles congruent, I'm going to need to prove this side is equal to this side. I'm going to need to prove this side equals this side. I already know PQ is congruent to SR because opposite sides are congruent. We also can say that this angle in the middle here is congruent by vertical angles. So we do have quite a lot of options. We can prove that the 2 triangles are congruent by side, 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 or I can choose side, angle, side. So because we did side, side, side the last time, I'm going to choose to prove those 2 triangles congruent by side, angle, side this time. So number 1, I'm going to say that diagonals, let's see, I'm going to say that my diagonals, PT, so PT is congruent to line segment TR, and I'm going to say line segment ST is congruent to line segment TQ, because in a rhombus, the diagonals, and this should be basically in a parallelogram, the diagonals bisect each other. And the reason for that is in a parallelogram, you could say definition of a parallelogram, but that the diagonals do bisect each other. In our definition, that's one of our definition of a parallelogram. Okay, So we have those equal. Now, all I need to do is either say PQ is congruent to SR, or I can say the angles in the middle are congruent, which I am going to do that. So number 3, I'm going to say that angle PTQ is congruent to angle RTS. And the reason for that is that vertical angles are congruent. And so now I have enough information to prove that the two triangles are congruent. So now I can actually just say for the 4th step that my two triangles are congruent. So I'm just going to borrow this one that we had from here. That I'm going to say those two triangles are congruent by side angle side. Now, just a note, again, instead of that, another option for number 3 would be that I would say PQ is congruent to RS, and the reason for that would be, again, definition of a parallelogram, in that opposite sides of a parallelogram are congruent. And then 4 would not be side angle side. 4 would be the same. I would still say that two triangles are congruent, but instead of saying side angle side, I would say side, 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 because then I have 3 sides. So that's up to you how you want to do that, because, proofs are, pretty unique to each individual, and you just have to decide how you want to work that out. We are trying to prove this, which it says if a quadrilateral is a parallelogram, then the opposite angles are congruent, which means that we're trying to prove that C is congruent to A. So we want to say that angle C is congruent to angle A. That's what we're trying to work out. So we do know that TUVW is a parallelogram. Given that it's a parallelogram, then we know that if it's a parallelogram, opposite angles are congruent. We know that opposite sides are congruent. We know, several different things. But what I would do right now is I would pause the video for a minute and work this out to see how you would do this, and then check back and see if this, is that the same thing. So for me, assuming that you did that, you turned it off, you turned it back on. For me, one of the things that they said was that TU is parallel to WV. Well, if two lines are parallel, then actually, if I know, so for this problem here, since we know that these two lines are parallel, that would mean that B, this segment, and A, this segment, are actually congruent. So I would say angle B is congruent to angle A, and the reason B and A are congruent is because alternate interior angles are congruent. All right. Now on the left side, they're saying that angle B, I'm not crazy about the way they wrote this, because you would need to write angle B is congruent to angle C. And the reason for that would be, for B to be congruent to C, would be because these lines are parallel. And I would have to say these lines are parallel. So I would have to say TW is not congruent, but TW is parallel to UV, to segment UV. And if I did that, then I could say B is congruent to C. So realistically, what we have is this. Because it's a parallelogram, both pairs of opposite sides are parallel. Okay? Check. Because it's a parallelogram, we know that angle B is equal to angle A. Alternate interior angles are congruent. We also know, because it's a parallelogram, that C would be congruent to B here. And the reason for that would be corresponding angles are congruent in a parallelogram. So I know that B equals C and A equals B. So by the substitution property, I can say that A equals C. And then you have a proof. All right, check. All right, given this figure, find the length of the diagonal. Now again, remember, we need a right triangle. So in this case, in this problem here, A right triangle would be this one right here. So that would be perpendicular here. And I'd be able to say a squared plus b squared is equal to c squared here. But I don't have this length right here. So in order for me to get this length right here, oh, I guess I shouldn't call it x because that's x up there. For me to call, I'm just going to call this, let's call this a, okay? In order to find that, I would need to use this triangle here, this right triangle, to find the length of a, which would go 4 squared plus 4 squared is equal to a squared. So we have what? 16 plus 16, which is 32, equals a squared. So a equals the square root of 32. So now, instead of a here, I'm going to erase this a, and I'm going to put the square root of 32. So now I can find x by using this length squared plus this length squared is going to give me that length squared, leg squared plus leg squared. So now I'm going to go for this triangle, 4 squared plus the square root of 32 squared is equal to x squared. Now, I know a lot of you want to take the square root of 32 and reduce that. Try not to do that if you can help it, because, you know, then you just have to square it. It's a lot easier. So we have 16 plus 32, which is 48, is equal to x squared. So my value of x, that length of the diagonal in the cube, is the square root of 48, which you're not going to leave like that. You're going to actually reduce that to root 16 times root 3. So we're going to get 4 root 3 is equal to x. So that's the length of the diagonal in that figure below. Now for this problem here, we're just kind of jumping around at this point. I want to introduce what is an exponential function and what the formula is. So this is the equation for an exponential function. An exponential function is a function, it's a graph or a function that actually increases very, very quickly, like rabbits multiplying, or, you know, something that like some sort of science experiment that the atoms are like tripling and quadrupling at a time. So this is an exponential function. This is my equation, which is a times b to the x power. The a is what we call the initial value. So if they say, hey, we started off with 400 rabbits, that's my initial value. That's a. The y-intercept is my b value, and the multiplier, or the b is the multiplier, but then to the power of is my x. So to increase or decrease a quantity by a percentage, you use that multiplier. That's your b value. For example, the multiplier for this equation right here would be 1.07. So if it says for an increase of 7%, that's going to be 107, right? But keep in mind, percent, we're going to move back 2 places. So we have 1.07. So that would be my, that's my multiplier. That's my b value, okay? So you're going to be given information, and you're going to have to put this into a form like that. So in your homework, you need to know what those values are, okay? For this problem here, this is not exponential, but what we are trying to do is we are trying to graph this inequality. Now, here's another new word. An inequality is something that's greater than or less than, you know, another value. So you're going to graph this the same as you would a line. Now, if this was a line, I would do this. I would start with -4, 1, 2, 3, 4, put a point there. That's my y-intercept. And then I would drop down 1 and go over to 3. Or I could go up 1 and to the left 3. So my line actually would look like this. Now, a couple of things about this, okay? This is what your graph would look like if it was a line, meaning if it was equal to. But the actual question says that it's not equal to, because there would be a line underneath it, but it's greater than that value. So what that means is that you're going to have to take this line, and it's not equal to that line. So what that means is that this line here is actually not equal to that. So we're going to call that dotted. So it's dotted because it doesn't equal it. Additionally, see how it's greater than? It says greater than. What that means is that all the values above that line would satisfy my equation. So like if I even just pick the point 0, 0, 0 is greater than negative 1/3 times 0 minus 4. So 0 is greater than 0 minus 4, or 0 is greater than negative 4. True. Any value that I pick that's above my line because it's greater than and not equal to would satisfy my equation. Now, I do want to make it very clear that you cannot choose any value on the line. So, for example, I cannot choose negative 4, 0, negative 4, because that would mean negative 4 is greater than negative 1/3 times 0 minus 4. That would say negative 4 is greater than negative 4, which is not true. So do you see how I picked this point, 0, negative 4, thinking that I would be able to plug that in and satisfy my equation, but it doesn't work because it's got to be greater than and not, it's not equal to. For these problems here, we're going to solve for x. So what we have here is, I know both of these segments are equal, and I am going to find this value here, because if these are equal, that is x too. And if this is a right angle, I know that this is 6, right? Meaning this is a 6, 8, 10. But if I forgot that, I can still say x squared plus 8 squared is equal to 10 squared, and use Pythagorean Theorem. X squared equals 100 minus 64, which is 36. And so x squared equals 36. So you would square root 36, and you would get 6. So x is equal to 6. For this problem here, if these are parallel, and we have opposite sides congruent, if these two sides are congruent, that means that this side is parallel to this. Now, if that's a parallel, then that means this is a parallelogram. And that means that whatever 10 is, x has to be the same. So that means x is equal to 10. Because remember, in a parallelogram, both pairs of opposite sides are congruent. So not only would this be 10, and this would equal 10, but that's 9. This would also equal 9. Solving for x in this problem here, it's not a special right triangle. It does look like both pairs of opposite sides are congruent, which means if I can find this value here, that this value is going to be the same value. Because it has 4 right angles, it is a rectangle, and which means both pairs of opposite sides are congruent. So what I need to find is the x, or I could just find the x on the bottom down here by moving this congruent to that. So I'm going to put myself here at this corner, and I'm going to use tangent, because tangent of 35 degrees is equal to the opposite side over the adjacent side. So I am going to cross multiply, and I'm going to say x times tangent of 35 is equal to 11. And then x is equal to 11 divided by whatever tangent of 35 degrees is. And so I'm going to use that on my calculator. Make sure you're in degrees. 11 divided by the quantity tangent of 35 degrees is equal to about 15.71. So x is approximately 15.7 feet, units, whatever. Okay. For this problem here, it says that AC and BD are straight line segments. Okay. I'm guessing we're trying to find x. Oh, yeah, here it says solve for x. These two angles are congruent. That means that this must be parallel. That means that 47 equals 47. And this angle here is congruent to this angle here. Well, that's just angle, angle, angle. And that's not saying that they're congruent. You can't say that two triangles are congruent by angle, angle, angle. I need a side. So before I can say 4 is congruent to x, I actually would need to say that they are straight line segments, but I'm going to also say that they are bisected. And if that's the case, if they are bisected, then I could say that x is equal to 4, because then it would be whatever, this would be this equal to this, and this side equal to this side. The two triangles are congruent by, angle, angle, side, and therefore 4 would equal x. But I would have to add some additional information in here, because this one you need additional information. All right. There's no figure below. Let me come up with a figure. Hold on. So in this figure below, we're going to find the length of this diagonal, which I'm just going to call x for right now. However, this one's a little bit tricky, definitely, because in order to find the length of that diagonal, I'm going to use this triangle, which I'm going to highlight like this. So this one straight down like this, and then across, because that's got to be a right angle, right? So the thing is that in order to use that side that goes straight across, I actually have to find the length of that diagonal, because I don't have that length. So I need this. This is a right angle because it is a rectangular prism. In that case, I know that's 3, 4, and that's 5. And then if you know your special, right, your triples, right, that's 3, 4, 5. And then you would know that that's 5, 12, and then x is equal to 13, right? If you didn't know that, and if you forgot, what you would have to do is actually you'd have to use Pythagorean Theorem twice. You'd go 3 squared plus 4 squared is equal to, well, this length here, we'll call that a squared. And then what do we have? 16 and 9, which is 25, so equals a squared. So then a equals the square root of 25, which is equal to 5. So that gives me this length. And then I would, number 2, I would go 5 squared plus 12 squared is equal to x squared, the biggest diagonal. So 25 plus 144, which is 169, equals x squared. So x would then equal the square root of 169, which that would make x equal to 13. So there are some runarounds for you to do with that. Either way is fine. So here's some just definitions, basic definitions of all the quadrilaterals that we've reviewed so far. Quadrilateral being a 4-sided polygon. A kite is a quadrilateral has 2 pairs of consecutive sides. So for example, this side's congruent to that side. In a kite, that side equals that side. In a kite, you also have diagonals that are perpendicular, and only this side and this side are bisected, those two. For a trapezoid is a quadrilateral with 1 pair of parallel sides. And so therefore, if it's a parallelogram with 1 pair of parallel sides, that would make this parallel to that right there, okay? A parallelogram is just a quadrilateral with both pairs of opposite sides, but in reality, we all know that the parallelogram has 5 really cool characteristics, and these 3 are special parallelograms. And so a rhombus is a quadrilateral that have 4 sides equal. It also has, if you recall, 4 congruent sides. It has the diagonals, which makes it super cool, are perpendicular. Also, the diagonals bisect the opposite angles. So that's important to know. A rectangle has 4 right angles. What's cool about a rectangle is that the diagonals, they're not perpendicular, but they are congruent. Whereas in a rhombus, they're not the same length. For a square has all the properties of a rhombus and a rectangle. So it does have 4 congruent sides. It does have diagonals that are perpendicular. It does have diagonals that are congruent. It does have diagonals that bisect the opposite angles. So in a square, if you're bisecting the opposite angles, right, with your diagonal, and you know that's a right angle, then you also know that these are 45, 45. A square is a quadrilateral with 4 sides of equal length, so it does have 4 equal sides like a rhombus, and it does have 4 right angles like a rectangle. So you're going to be using your understanding of congruent triangles to prove properties. and of rhombi and practice using a flowchart to organize a proof. You're also continuing to develop flowchart proofs as well as 2-column proofs. So your homework tonight is for 7.2.2 and 7.2.3. And if you have time, get ahead because you have a worksheet that also is going to be due, and that will help you study for your test coming up. So good luck. Thanks so much for watching. I hope it helped.